Yeah, okay. So the next question we are going to solve is going to be question 3B, where we are asked to write a VHDL code for this circuit. Okay, so if you are trying to write a VHDL code, it has a specific structure, and the structure includes the definition of the library you are making use of, the definition of the package, which is basically just importing the package you are going to make use of. Then there's something we call entity. Inside this entity, you define things like your ports. So now each of these entity has an associated architecture. That is, you can associate an architecture to this entity. So this architecture contains the actual code that is executed based on what you define in this entity. So now after that, I think that's like the major thing we need. So we need the library, the package from the library, the entity, and the architecture. So now let's see how those works together. Let me see if I can fit the code into this page, or let me just open another page. We'll always refer back to this place. So that's going to be 3B code. Now I said the first thing we need to define is our library, right? So the library that we're going to make use of, and why do we even need the library? The reason we need the library is that each of these ports are going to have a data type, and the data type they are going to have is going to be std logic. So std logic is more of like a data type that is built into VHDL. So now this std logic has to be imported from the IEE std package. That is, the std package is in the IEE library, so we have to import both the library and the package first. So let's see. Now if you are trying to make use of a library, you basically use I'm coming, sorry. We have, if you are trying to make use of a library, basically just say library IEEE. So this is library I'm making use of. Inside this library, we are making use of a package called use IEE. So we are using this package inside this library, and the package name is std. I think it's std logic or std lib. I can't really remember. Yeah, it's std lib. std lib 1164.0. Yeah, so okay, we have to make use of this library inside this. Now the next thing we need to define is our entity, and when you are defining entity, you just basically say entity, you give name to that entity. Let's give a circuit. So circuit is going to be the name of this entity. Entity circuit is. Now inside this entity, I said we are going to define the ports that we are going to make use of. So the ports that we are going to make use of is going to be the next thing we need to define. Ports. Now if you look at the circuit that we have 3 ports, W, X, Y, which are the input port, and we have Z as our output port. So these ones are the inputs, these are the outputs. So when you are defining a port, the way you define a port is the port name, the data direction, and the data type. So now in our own case, we notice that W, X, Y are inputs, right? So if you are defining that, that's going to be W, X, Y, and all of them are going to be inputs. And the data type, which is which is the major reason we are making use of this one, is going to be std lib. std logic, sorry, std logic, then this. Then the output, which is Z, is going to be output std logic. Since this is the last port, we don't need a semicolon after this one, so we just basically close off that bracket, and that's going to be the end of the entity. So we are basically going to end the entity name, which is circuit. Now we need to associate a specific architecture to this entity, and the architecture we are going to associate with it, we have to define it. So architecture, so the name of the architecture, let's call it Boolean function. So what are we associating this architecture with? We're associating it with circuit entity. So that's going to be of circuit is. Now inside this place, we need to write the code that will actually execute this, that represents this circuit. So it's going to be a little bit complicated if we write it at once. But what about we just basically put this one here? Let's call this whatever the output of this one as L, whatever the output of this one as L, and whatever the output of this one as N. So all these ones that we have here, L, M, N, we call them signals. So they are an object type, and they are called objects signals. And these signals are the first thing that you define in an architecture. So you are trying to make use of the signal, you have to define them inside an architecture. So we have signal LMN. So we have to declare them. The way you declare a signal is this: signal L M N, and what's going to be the data type? The data type is still going to be std logic. Now if you look at this one, L is the NAND gate of W bar, X bar, and Y bar. So that's what we are going to have is W bar and X bar and Y bar, all of this knotted. So that's what we are going to have for L. So let's see how we are going to do that. So this is going to be L is equals to, so this is like the equals to sign in VHDL. So for signals, actually it's only signals and ports I think that make use of this one. So we are going to have L, we said is going to be equals to not of W bar. So if you want to represent W bar, it's also going to be not W and not X, not X, and not Y, and that's not Y, all of them close brackets. So that's for L. Now we need for M, what's going to be M? So M is going to be X and Y. So X or X and Y is going to be M. So M is equals to X or Y. So that's going to be our M, and our N is going to be W X bar. So W X bar, that will be W, is that hand gate? Yes. And X bar, that will be not X. So the final expression is now going to be equals to the all of everything. So which is going to be the output. So the output Z, which is this one, will now be equals to L or X, I'll be sorry, L or M or N. So we said Z is equals to L or M or N. So let me cancel this line here. So that's the end of our architecture. So the next thing we just need to do is to end this architecture. Ending an architecture is just basically putting the end and the name of the architecture, Boolean function. That's just all. So that's going to be the code for that circuit that we have.